Assalamualaikum and good evening. Today our group, which is group 10 from section 4, will presenting our structural design project. These are our company organizational chart, which is led by me, Afiq Shahmi, and Khairul Ikwan as the project manager, and lastly, Faris Daniel as the general manager. For introduction, the objective and purpose of this project are to produce a comprehensive structural design of a one-story residential house located in Paguh, Johor by adhering to Eurocode standards to ensure structural safety, functionality and compliance with current engineering regulations. The structural layout is developed based on the architectural plan to accommodate and safely transfer the applied loads through appropriate structural members such as beam, columns, and slabs. These components are carefully designed to resist various types of load, including dead loads, live loads, wind loads, and potential seismic action. The project aims to highlight the importance of accurate load distribution, effective reinforcement detailing, and proper structural member sizing, which are crucial to ensuring the long-term performance, durability, and safety of the structure. Structural stability and integrity are essential not only for the protection of occupants but also for minimizing maintenance costs and extending the service life of the building. For analysis of action, we need to know our QK and GK, which is permanent load and variable load. And then we also need to know our thickness for slab, beam, and column. We also need to find our FS for each slab to know whether it is one-way slab or two-way slab. And then we need to draw out our two-way slab for each slab. After we determine our slab, which is the two-way slab, we need to calculate for each edges. For FS1, we take it as case 4, which is two adjacent edges discontinuous. And then we can use it from the table and insert it into the formula of BVX and LX or BVY and LX. And then we need to calculate each of the continuous edges and the discontinuous edges. After we find our value, we also need to calculate our action on beam. We need to find our QK and GK, and then after we find the new QK and GK, we need to insert it into the W formula, which is 1.35 GK plus 1.5 QK, and then we get our W formula for each of the beam.
Okay, next for this slide, we're gonna go to chapter 4, which is design of reinforced concrete beam. So as you can see, is one of our group calculation for this chapter. Okay, firstly you need to decide which beam you want to calculate. So firstly, you need to find imbalance and moment to find which type of reinforced beam. So there's two type of reinforced beam, which is singly reinforced, where beam was reinforced by tension steel only, and for the second type is doubly reinforced, which beam was reinforced with compression and tension steel. So how you gonna to decide that? So if moment balance was below 10 moment, it was doubly reinforced, and if moment balance was bigger than moment, so it was singly reinforced. So next we're gonna go to the next we're gonna calculate the ultimate moment resistance of section. So as you can see here, we number 4, we calculate to find if compression steel is achieve its design strength. And for the 5, we calculate the level arm for this beam. So we're gonna go to the right side calculation. So here you can see that the how many steel bar that provide in this beam. So next we're gonna go to the shear resistance. So we need to find the effective depth first, and next we're gonna calculate the concrete strut capacity. Next, for this slide, it was continuing the last calculation. So after we find the concrete strut capacity, we're gonna calculate the shear length and maximum spacing of steel bar. So next we're gonna find the minimum length spacing and shear resistance of minimum length. And the last one, we're gonna sketch the link arrangement for this beam.
Next part is we are going to chapter 5, which is design of reinforced concrete column. In this chapter, we focus on the design process for reinforced concrete column, which are critical vertical structural elements that transfer loads from slab and beam down to the foundation. The first part of the page shows column layout plan. For each column is labeled and placed according to its grid location. This helps in identifying the position and spacing of column in the overall structural system. On the right side, we have the design calculation for each individual column. This calculation typically include the first one is axial load and moment acting on the column, and the second one is required steel reinforcement areas based on the loading. The third one is check for minimum and maximum reinforcement ratio, and the last one is selection of appropriate bar size and arrangement. Each column is designed to ensure it meets the required strength, stability, and durability according to the code provision, such as Euro Code 2, depending on the standard used. This design step ensure that the column can safely support both vertical loads and bending moment, especially in multi-story building. The conclusion is proper column design is crucial in preventing failure and ensuring the overall safety and stability of the structure. The reinforcement details derived from this calculation are then used in the construction drawing for site implementation. Continue from the previous part. This section shows the detailed step-by-step calculation for a specific column. Labeled as column A1, the purpose is to verify its structural capacity under the applied loading condition. Here we start the loading assumption, including axial load and the corresponding design moment. These are typically derived from load combination based on structural analysis result. Then using formula from structural design codes or Eurocode, the following parameters are calculated. The first one is effective depth and overall dimension of the column, and the second one is interaction ratio between axial load and bending moment, and the third one is required reinforcement area for the given load condition, and the last one is check for the neutral axis position to determine the stress block. The right hand page includes further calculation using interaction chart or design formula to verify whether the selected reinforcement satisfy both moment and axial load requirement. You can also see a small bar arrangement sketch indicating the final reinforcement layout. And the key point from this calculation is demonstrate how structural engineers manually check and optimize reinforcement design, ensuring the column is both safe and economical. And by working through this process, we ensure the column can resist combined bending and axial force, which is essential for preventing buckling and crushing failure in reinforced concrete structures.
For design of reinforced concrete slab, we need to calculate each of the slab to determine the suitable design of concrete slab that will make sure our slab is strong and and has strong durability. First, we need to find our Ly over Lx, and then after we find the value of Ly over Lx, we need to interpolate from the table, and then we will get the value of sigma y and sigma x. And then we need to write down our specification and then assume our diameter of bar. And then we need to calculate our thickness for deflection. And then after that, we need to assess our durability for which is the ceiling, the fire resistance, and so on. And then after we assess our durability, we will get our value for the C nominal. And then we need to use the C nominal for our next calculation. After that, we need to assess the action on slab. We need to use our GK and QK, and then we need to find the design action, and then we need to consider it as 1 meter width, and then we need to find the critical moment and shear design. Shear forces. For shear forces, the formula is VED equals to WL over 2, and then the bending moment formula we need to find for MSX and MSY. And after that, we need to design the main reinforcement using DX and DY. And then we need to calculate the short span using the balance formula, which is 0.167 FCK BD square. And then after the calculation, we will get the value, and then we need to compare it with the table given, and we will get the provided value and the provided design for the short span. And for the long span, we need to use the same imbalance formula, which is 0.167 FCKBD square, and then we will get the value as the short span. And then we will need to come out from the table, and we will write down the provided value from the table, and then we need to compare the value from the table and the value from our calculation. And lastly, we need to calculate the minimum and maximum AS. For AS minimum, the formula for the calculation is 0.0015 BD, while the formula for AS max 0.04 AC.
So next we're gonna go to the Start Pro design report. This is a summary of the structure analysis result together by Step Pro software. The table you see right now is it show about the beam force detail and plane center stress summary. So let's look at the beam force detail first. So this table show the internal force and moment for each beam element in structure. It also include with axial force, shear force, torsion, and bending moment. So for example, the maximum axial force record is 29.99 kN, while the maximum loading bending in the Z direction reach 420.546 kN meter, this is a significant moment. So this value help us check if the beam section and reinforce are sufficient under loading. So next we're gonna look at the second part, so which is about plane center stress summary. So about this table, it also include the normal stress, shear stress, principal stress, and warm miss. So as we can see, the maximum warm miss is around 710 kilonewton per meter square, which is within the concrete capacity, so the slab is considered safe. This stress value ensure the slab will not crack and fail under the applied load. So in conclusion for this slide, this report from Step Pro confirm that structure moment for this report from Step Pro confirm the both beam and slab are performing well under the given load and all value remain within acceptable safely limit.
Now we are going to conclusion and summary part. I will be presenting about comparison between manual computation and StatPro. StatPro use a stiffness metric approach to analyze 3D structure, handling load like dead load and live load. And load combination automatically is provide accurate result for this displacement, force and moment calculation. For example, it record the first one is maximum axial force is 867.019 kilonewton. The second point is maximum bending moment 1221.818 kilonewton meter, and the third point is maximum Y displacement 3.373 mm. This result fall within safe engineering limit, showing the structural integrity is maintained. Manual calculation, while based on simpler assumption, are still useful for verifying software outputs and understanding basic structure behavior. For the conclusion, StatPro is more accurate and suited for complex analysis, while manual methods are best for smaller structure or result verification.